So we are going to draw a diagram for total internal reflection and refraction through a 30 degree, 90 degree, 60 degree or simply right angled prism. So as you can see, I have drawn the cross section of such a prism. Now what we are going to do, we are going to take an instant ray of light this way. It's going this way, it's entering the prism at point Q. And this point, you see, this is 90 degrees, so it passes undeviated. Now where it is striking, we have to draw a normal perpendicular to the surface. Now here, consider this triangle. This, I said, was 90 degrees, that's why it's passing undeviated. This is 60 degree. Now the total angle, the sum of all angles in a triangle is 90 degree. So as per that, this should be 30 degree. If this is 30 degree, then this is 60 degree. Why is it 60 degree? Because this whole angle is 90 degree because we have drawn this normal perpendicular to the surface, right? So this is 90 degree, this is 60 degree, and this will be 30 degree, so that this whole is 180 degree as per a triangle. Now if this is 30 degree, then this is 60 degree. If this is 60 degree, we know the critical angle for the pair of glass air interface is 42 degree. So here 60 degree is obviously greater than 42 degree. So this ray is going to suffer total internal reflection. So the angle of reflection will be equal to the angle of incidence. This way. Now here, once again, we are going to draw a normal. Your normal. Now we need to know this angle. Now you can see this is 30 degree and this was supposed to be 90 degree. If this is 90 degree, then this is also 90 degree. So this was 60 degree. That means this angle is 30 degree. If this is 30 degree, then this 30 degree plus 30 degree, 60 degree, this should be 90 degree, which is true because we have drawn a normal. Now what do we find? We find that this angle is 30 degree. Alright, this angle is 30 degree. Now, since the ray is traveling from glass to air, it will bend away from the normal as its speed increases. So it should go this way, but instead it will turn away, so it will go this way. It will exit this way. It was supposed to go this way. It was supposed to go this way. But what does it do? It bends away from the normal. And so it comes out. This is your emergent ray. This is your incident ray. Now if you want to show the angle of deviation, you will simply trace back this emergent ray. Traced it back. Now I'm pretty sure it's not that clear, so I can just erase a few parts. So this was the 60 degree we were talking about, and this angle, when we trace back the emergent ray, the angle we get over here on the incident ray is the angle of deviation. So your diagram is complete. That's all you need to draw.